The last topic in this video series is going to be regular expressions. Regular expressions can become quite complex. I'm going to give you just a hint of that. But if you know just some of the basics that we'll review going through the tidyverse functions in R, they can be very powerful for when you're working with strings. Let's start with what are regular expressions. Regular expressions, also known abbreviated as regexps or regex, are sequences of characters that define a search pattern. Regexps consist of characters and metacharacters. I think Hadley Wickham had it right when he said the following. When you first look at a regexp, you'll think a cat walked across your keyboard. But as your understanding improves, they will soon start to make sense. Let me show you some examples of what he's talking about. But the first thing I want to do is show you something that is not a regular expression, because showing this to you will give you the idea of what regular expressions are all about. Now, I don't know if all of you have seen this. You actually have seen it in the context of our gitignore file when I've used an asterisk. The asterisk here is called a wildcard. That is, it stands for any character or sequence of characters. So if I were to put this in my gitignore file, it will look at this as any characters followed by .txt, which I don't know about in OS X, but in the Windows world, that is what we use as a suffix for a normal plain text file. So if I put in gitignore star.txt, which by the way I should not, because a lot of the files we work with are normal text files when we're doing Git projects, but we have done it before for HTML. We've used asterisk.html, and that basically says any file name that you see that begins with any sequence of characters but ends with .html, ignore it. This wildcard refers in general to anything followed by .txt. The asterisk in this expression is what is known as a metacharacter. That is, it's a character that's meant to refer to a group of other kinds of characters. So we're not interested in it as an asterisk. We're interested in it representing any characters. It's not a character we're looking for, but tells us something about the characters that we are looking for. Here's how we would write this same thing now as a regexp. We would put caret dot asterisk backslash dot asterisk dot txt $. That is the regexp expression for look for everything that has any set of characters followed by .txt. Let me give you another example of a regexp so you can better see what Hadley Wickham meant when he said it looks like the cat walked across your keyboard. That's kind of what this looks like the cat walked across the keyboard. Actually, what you're looking at is a very powerful regexp. This is a regexp that can find email addresses in text. You could have 5,000 rows of data and maybe even have one column designated for email addresses. You could use this simple expression to verify that all of them are valid email addresses. Imagine that. Imagine setting up, for instance, a little R function in which you collect the vector of character strings that are supposed to be email addresses, and then go through each of them with this expression and put true if it's a valid email address and false if it's not. That is, create another vector that's illogical. That would help you readily identify all of the invalid email addresses. That's a whole lot better than being a graduate student who a professor hands you the 5,000 rows and says, would you check that these all look like valid email addresses? Well, now that you know regexps and, well, you don't know them yet, but you're getting the sense of it. You know it exists. And now that you know that and are, you could say, why, certainly, and come back to them 5 minutes later, hand them the list of valid email addresses, and have them give you a startling look as though you did not do your job. I'm not going to go through all of what these symbols mean, but if you want to take a few moments to pause this video and look to see how this works, you can look at these little boxes that explain everything here. This says matched anything contained within these square brackets. This W \W is a meta character for any character A through Z, upper or lowercase, and any numbers 0 to 9. Then we have allowances here for periods and underscores and percents and pluses and so forth. All the way to the end here where you have curly brackets saying you need to match this at least 2 times but no more than 4 times. So this is a email matching example to show you the power of regular expressions. There's a great site that I'm going to give you a link for on Blackboard that goes through regular expressions, and it's a tutorial so you can learn as much or as little as you want about them. In fact, one thing I like about the tutorial is that they have a short tutorial and a long tutorial, and they're linked together. So you can read the short tutorial to kind of get a flavor, but for any topic you want to know more, you can click the link to the longer section in the long tutorial and learn more about it. So I'll post that in the Working with Strings folder that you've been working with right after the video series in case you want to go take a look and learn more. So we're going to look at regexps in R and the tidyverse, but we're not going to get very complicated. But what we are going to do is look at the power of these even when you use the simple examples. And those are the examples you'll probably use most of the time. The one I showed you for email addresses is certainly useful. You can look up many more on the web. In fact, that site I told you about with tutorials also has common examples, and it has a lot of useful regex that you can cut and paste. You can copy over, just like this email one, to be able to help you in your research projects in which people might giving you text for various purposes. Many languages recognize regex, and guess what? R is one of them. I looked recently at a list of languages. I think there's something like about 15 of them that recognize regexps, and R was on the list. The tidyverse includes functions for regexps. Regex can be combined with string functions. So you can use string view for testing one. You can use string detect to find a pattern match in a character vector. And you can use string subset, which will pull out strings in a character vector that match the pattern. So that's an introduction to regular expressions. And now you'd like to see them in use. So we'll do that in the next video.